This is second part, lesson 2, week 5. Crystal structure continues. We'll be looking at surface tension. Surface tension is the force that acts on the surface of a liquid and make the liquid behave as if it were covered by an elastic skin. Looking at the diagram we have there, so surface tension is being demonstrated with the aid of that diagram. Coefficient of surface tension. The coefficient of surface tension of liquid is the force acting normally per unit length on a body on the liquid surface. The coefficient is being represented by letter Y of the surface tension, where letter L represents the length of the body on water, and letter F, surface tension, represents surface tension. Molecular explanation of surface tension. The molecules of a liquid attract one another due to the cohesive force between them, but the molecules on the surface of any liquid are always attracted downward with more forces. That's how they are attracted upward, since the vapor molecules outside the liquid are few when compared with liquid molecule inside. The resultant attraction to the liquid molecules at the surface is downward. This resultant downward force on the surface molecule makes the surface of a liquid to be under tension. We have the diagram there. Surface of any liquid behaves as though it is covered by a stretched membrane, an elastic skin. Net force on molecules at surface is into bulb of the liquid. Then we have the effect of surface tension. 1. Surface tension can make steel needle float on water. 2. Water droplets from top are spherical. 3. Water poured into a cup will rise slightly above the ring of the cup without overflowing. 4. Paint brush deep in water spread in water but cling together outside water. 5. Surface tension prevents water from passing through the fabrics of canvas, raincoat, and umbrella. And the diagram below demonstrates that is, surface tension prevents water from passing through the fabrics of canvas, raincoat, and umbrella. Then we have that other diagrams which demonstrate the effect of surface tension, like the droplets, rate of droplet of water, droplet from top, which are always spherical. Droplets, you can see that being demonstrated, droplet is spherical. The factors that affect surface tension, TIN, the abbreviation for that, where T represents temperature, I represents impurities, and N represents nature of this liquid. So we'll be looking at this factor one after the other. 1. Temperature. Increase in temperature, that is heating, reduces the surface tension of a liquid, since the surface expands on heating, while decreases in temperature, that is cooling, increases the surface tension, since the surface contracts on cooling. 2. Impurities. Adding impurities like soap or detergent solution, alcohol, kerosene, reduces the surface tension while liquid with higher density, e.g. palm oil, if added to water, will increase its surface tension because of its viscosity. 3. Nature of liquid. Volatile liquid that are easily dried off when pure on the surface of an object or when pure. Have low surface tension, while liquid with high viscosity, e.g. palm oil and engine oil, have high surface tension. What do we understand by viscosity? Viscosity is the friction that exists between two layers of a liquid sliding over each other. Some liquids flow more easily while being pure than others. Liquid like honey, palm oil, engine oil, and syrup, which flow slowly while being pured, are called viscous liquid. The resistance to motion, that is, viscous force on drag, V, is high in viscous liquid, thus opposes the motion of object falling through it with two forces V and U. That V is the viscous force and U is the upthrust. The diagram shows talk more on viscosity. We have water when pured. You can see how it moves. And we have milk. We have oil. We have light syrup. We have heavy syrup. And we have chocolate syrup. So all this. Then we have another diagram below it, which tells us more about viscosity. We have water. If water is stirred, you can see the stirrer move easily. But with liquid of high viscosity, take for instance syrup, when it's being stirred, doesn't move easily as it's being demonstrated in water because of the low viscosity of water. So the syrup, and that shows that syrup is of more viscous, that is, it has a high viscosity than water. So when it is being stirred, it's not moving easily as it occurs in water. Terminal velocity. When a body falls through a viscous liquid, it is opposed by two forces, V and U, the drag force and the upthrust, and it moves with a velocity which increases as the body falls through the liquid. This velocity eventually becomes constant at a particular maximum value. Terminal velocity is the maximum constant velocity attained by a body falling through a viscous liquid. We have the diagram, shows the direction of viscous drag, the upthrust, and the weight. The viscous drag is always pointing upward, the upthrust too pointing upward, and the weight always point downward. So W represents the weight of the body in Newton. V is the viscous force or drag, also in Newton, and U is the upthrust, which also acts in Newton. So since F is equal to ma, and the resultant force F here is W minus V minus U, then we say that W minus V minus U is equal to ma. where m is equal to mass of a falling body in kilogram and a is the acceleration in meter per second square. Then we have the diagram also which shows a light body and a heavier body with parachute. So, and that tells us when the two are dropped from the sky, there is influence of gravitational force or force of gravity acting on the two, and the parachute with a heavy body lands first before the parachute with a light body. I think we have that. Determination of terminal velocity. Apparatus, long measuring cylinder, engine oil or glycerol, a small metal ball, rubber band, and a stopwatch. Procedure. A steel ball of diameter much less than the diameter of measuring cylinder is allowed to fall in a cylinder filled with glycerol or any other viscous liquid. The ball attains terminal velocity before the point A. Two rubber bands are placed at 2 points A and B such that AB is 8 centimeters. A stop clock is used to time the fall of the steel ball between A and B. The experiment is repeated to get different values of height, that is H1, H2, H3, H4, and H5. 4. The steel ball is falling with a constant velocity. H1 over T1 is equal to x, H2 over T2 is equal to x, H3 over T3 is equal to x, H to H6 over T6 is equal to x, where x is constant velocity or terminal velocity. Application of viscosity. Reduction of friction by viscous liquid, e.g. oil. Parachute with large surface area reach terminal velocity faster. And knowledge of viscosity is used in construction of airplane and modern cars. That's the end of the class. Assalamu alaikum warahmatullahi wabarakatuh.